Friends, good evening. So I'm Haripriyakar, Assistant Professor Junior at Vellore Institute of Technology, Vellore. So today I will share a topic, and basically today I'm interested to teach the basic concept of the design and analysis of algorithm, because many students from various institutions are contacting me that, madam, we don't know data structure, kindly teach us something regarding design analysis of algorithm and some concept of the data structure. So before starting with this subject, I want to share certain concept and certain techniques with you, so that how can easily you can relate and you can understand the basic concept of this subject, and it will be gives you more knowledge. So first of all, whenever you are understanding this subject, you be strong in the algorithm part. Okay, that is one context. And another thing is, you have to very strong in data structure. Even you have to strong in queue, linked list, array. So whatever the concept is there, that you have to be fully, depthly you can understand, and you can slowly try to analyze the concept of the data structure, then you can relate it with the algorithms. So anyway, in this class, I will teach you the basic concepts, as well as how you can able to be boost up the concept of the data structure algorithms. So now we'll start. So today I will share with the introduction. So basically, what we are going to be planning this model. First of all, we can go with the describing the problem, and what are the stages of algorithm developments is there. Then identifying a suitable technique, design of an algorithm, and next we'll move with the time complexity analysis. Then after all, whenever you are doing the algorithm implementation, understanding, without the proof of correctness of the algorithm, you cannot able to be implement and prove algorithm. So for that reason, proof of correctness of the algorithm is very important. And next we'll move with the techniques. First of all, greedy technique, that is fractional abstract problem and Hoffman coding. Then gradually, after understanding the greedy techniques, we'll be move with the divide and conquer approach. And what is the concept of divide and conquer approach with maximum sub array? Then from there, how the correct to a first integer multiplication algorithm is uh, can be solved by the help of divide and conquer. So let's start. So first of all, understand whenever you are working with a problem or working with the algorithm, you have to be always identify a problem. Okay, and you have to precisely identify the problem and first step which is involved with it. Okay, so then only you can able to be work with the algorithms. So first of all, some examples of problem involving numbers, string, mathematicals. I can show it to you, like how the mathematical constructs can be happen. So basically it will be happen with the numbers, determine their sum product. Then you can go with the two numbers, then you can compute with the greatest common divisor, then sequence of strings, find the alphabetically sorted permutation of the sequence, or two arithmetic expressions and find out if they are equivalent. And after all, you have to move with the programming languages also. You can implement it. You can do with C or C++ or Java. And you have to create an equivalent program in bytecode. That is very important, because nowadays Python open source is very available. People can use with the VS Code and do it. But if you want to really learn, you do it with the C and C++, so that what will be happen, you can able to be do with like without copying the context, and you can analyze it properly. And coming to the examples, like routing problem is there over the W3 also you can check. Then identifying the efficient airline routes, identifying security vulnerabilities, computer vision problems. Many examples are there which is relating with the real world approaches. So this is the main context of the what design analysis algorithm. First of all, you have to design a problem, then analyze it, then you can go with the algorithm implementation. Okay. So next is, So whenever you are going to be work over the algorithms, so what are the context is plays a very important role. First of all, data structure, algorithm, programs. So first you understand what is data structure. Data structure is organization of data to solve the problem at hand. Okay. So that the concept I said, like it may be the array, it may be queue, it may be linked list. So first of all, organization of data is required to solve the problem. Whatever the problem is analyzed, to solve that, we need to be organize the data. That is data structure. So for that, we are having certain data structure types that we will be see while we will be processed. Then what is algorithm? Algorithm is the outline, the essence of computational procedure or step-by-step instructions. So easily you can remember that is a step-by-step instruction. Suppose I am telling you want to prepare rice or you want to prepare tea. For that, what you need? You need certain instructions. So that is algorithm. Before going to do, okay, whatever the instructions, step-by-step procedure or instructions following, that is algorithm. Okay. So what is the steps are involved in the particular problem? Then what is program? Program is implementation of an algorithm in some programming language. First of all, you have to design the step. Once you design the step, there itself the instructions will be available. Based on the instruction, you can write the particular algorithm in C language, C++ language, or Java language, any programming language or Python, anything you can choose and implement the particular algorithm throughout the programming language. So this is about the program. Okay, so now you clear with data structure, algorithm, and program. First of all, data structure is organization of data to solve the problem, whatever problem is given. Next one is algorithm. Algorithm is the outline, the essence of computational procedure, which is we have to follow the step-by-step instruction to solve a certain problem. Program is what? Implementation of an algorithm in some programming language. Some programming language means any programming language you can take here. Okay. So next one is problem solving steps. So what are the problem solving steps? We have to use it. So first of all, precisely specifying the problem. So first of all, whenever we are trying to solve a particular problem, we have to precisely specify the problem. This is very, very important. And design the algorithm to solve the problem. Then after you have to, once you specify the problem, suppose in your research you want to identify a particular problem. First you identify the problem, then you have to design the algorithm, like what are the requirement or what are the instruction needed. Okay, that is the algorithm. Implementing the solution as program. After that, what you have to do? You have to implement the particular solution as a programs. Then after the implementation throughout the program means here in this step, this is your program. Okay, this is your algorithm. This is the particular problem. Okay, so once you implement the solution by the help of program, then verification and validation of the program. That means whatever the program I implemented, whether that is validated correct or if not, that you have to do the verification. Okay, that is verification and validation of the implemented program. Whatever the program you implemented, that you have to check it. Okay, and next one, algorithm development for problem solving. Okay, whenever we are developing the algorithm for problem solving, what are the required things are needed? So first of all, input specification is very important. So what input I have to take, whether I am taking a strings, whether I am taking the numerical values. So I have to understand my type of input. Like suppose I am doing research, I have to do in image data, or I have to do with numerical data, or I have to do with video data, that I have to identify. So that is our input specification. Algorithm is, again, whatever the input I got, step-by-step instructions I have to write. Then I have to make it in the program. Then output is specification as function of input. Based on the input, what is the specification? Okay. Next, algorithm is describes the sequence of actions performed on the input data to achieve the output. That means whatever the algorithm we are using or we implemented, that will be work over the input data to get the output, that is to achieve the output. Okay, there can be multiple algorithms. So it can be multiple algorithms to solve the same problem. So one problem we can able to be solved with various kind of algorithms. Okay, analysis of algorithm helps to choose the efficient algorithm. So why we can use the multiple algorithms? Here throughout the multiple algorithms, we can able to understand which algorithm is having the less time complexity, space complexity. So accordingly, we have to choose the particular algorithm. Okay. So next one. So these are all introduction stages of algorithm development. So to develop a algorithm, we need various steps. So there are certain stages of algorithm development is there. First one is specification of algorithm. Next one is designing an algorithm, including the data models to use. Okay. Then checking the correctness of algorithms, analysis of algorithms. The next one is implementation of algorithm. Sixth one is experiment different variables in algorithm. Whatever the steps I said, like the specification of algorithm, we have to specify the algorithm, then we have to design the particular algorithm, then we have to, after designing, we have to prove it, proof of correctness. That means we have to validate whether my algorithm is whatever I designed that is correct or not. Then we have to analysis of algorithm is time complexity analysis, space complexity analysis. After that, implementation of algorithm. That means here we can get the output. Then experiment different variables in algorithms. So we can go with the different variables in specific algorithms. So this is called stages of algorithm development. This is very important. Whenever we are going for any competitive exam, we can get this kind of question like what are the stages they can give, they can ask us. Next one is identify suitable design technique. Okay, what types of implementation you are doing, that is very important. Recursion of or iteration, exact or approximate, serial or parallel, which design method you are using, whether it is a greedy design, whether a divide and conquer approach, dynamic programming, backtracking, branch and bound. So these are all various kind of methods are there. Greedy method, divide and conquer method, dynamic programming method, backtracking method, branch and bound method. Then you have to understand which approach, whether you have to go with the top-down approach, whether you have to go with the bottom-up approach. Okay, then time and space. This is very important. So as I said, once you analyze or implemented the algorithm analysis is primarily focused on time. That is processor speed determines the actual time. Processor speed means how much time it is taking to execute certain program. Not possible to change for given hardware. So we can't change with the specific hardware. So if I'm using i7 processor, so based on my processor, the time will be different. Somebody is using i3 processor, for them time will be different. So not possible to change for given hardware. We can change the time analysis or a time complexity, whatever is coming. Processing speeds hitting the cap. So processing speeds will be hitting the cap based on the processing speed. Then space depends on available physical memory. What is the memory is available? Based on that, it will be take the space. More space can be made available by reconfiguration and enhancing. We can enhance and we can make the space. So algorithm analysis will be primarily time oriented. Basically, whenever we are doing the algorithm analysis, it will be primarily time oriented. Okay, so based on the time. Next one is measuring time. How we can able to be measure the time. Actual time variables on the hardware cannot use actual time for efficiency comparison. We can't compare. So measurement to be done in terms of basic operations. Like basic depends on the language, like which language we are using, C, C++ or Java. So it is considered as the basic operation. So you can take the example comparing two variables, assigning value to a variable. So you can take two variable, you can assign the value for a specific variable and you can check what is happening. So that is called measuring time. Next one is input size and input type consideration. Based on input size also how it is work. Running time depends on input size always. That is n, and input type. The larger the input size, longer it takes to complete the task. Based on the input, like suppose I'm using the video, so it will take more time. If I'm using just a image, it will take less time. So based on the input size also, sometimes it took the time, like how much time it is taking to complete the particular task. Running time for inputs of same size variables with input type. So running time for inputs needed the same size varies with the input type. It is varies based on the input type, what type we are giving. For sorting algorithm input size, like number of inputs algorithm need to sort. So this is for the particular sorting algorithm. Input type already sorted. Rigor sorted, best case, worst case, average case. So here three cases there. It will be goes with the best case, worst case, and average case. Typically, analysis done for large input size. When we are going to do the time complexity analysis, we can do for the long, like a very large data set will be there, means we can check the time complexity. Worst case estimation, because worst case will always give the reduction of time complexity. Worst case means it will goes with the high. So running time is taken as function of input size T of n or